I'm Jessica Santillo, and I'm going to present the work called Use of Measurements in Worst-Case Execution Time Estimation for Real-Time Systems. This work was done by me, Romulo, Silva de Oliveira, and Luís Arcaro at Federal University of Santa Catarina. Real-time systems are computational systems that are subject to temporal requirements. In order to ensure compliance with deadlines, the worst-case execution time of each task should be estimated. The increase in processing and efficiency needs has created demand for the use of processors with ever higher levels of complexity. In this context, probabilistic statistical execution time analysis methods emerged as a new approach to overcome the limitations of traditional statistical time analysis methods by providing probabilistically safe WCET estimates. The main contribution of this work is an experimental evaluation of the applicability of measurement-based probabilistic time analysis in the specific case of an operating system relevant to real-time systems, and using a processor with complex acceleration elements. In order to do so, an OS based on the RINC653 specification is used, which defines a real-time operating system interface for avionics systems. Probabilistic temporal analysis employs statistical methods for providing WCET estimates. This work focuses on measuring-based probabilistic time analysis, which sets probabilistic thresholds for the WCET of tasks. The so-called probabilistic worst-case execution times are composed of a threshold value and an associated probability that it is exceeded in any individual execution of the task. The main tool currently employed by MBTA is extreme event theory, a branch of statistics designed to estimate the probability of extreme events. An estimate of the WCET of a task can be obtained at a certain level of statistical confidence using measurement to obtain data and EVT to model the distribution of extreme execution times. The application of EVT by MBTA can easily be divided in 6 steps. Step 1 is to collect a representative sample of execution times. Step 2 is to check the adequacy of the sample using appropriate statistical tests. Step 3 is to use a specific method to select sample values. In this work, we use block maxima, which divides the sample into fixed size blocks and retains only the maximum value of each block. We then fit a distribution of the GEV family to the resulting set of values. Step 4 is to estimate the distribution parameters. In this work, we use maximum likelihood estimation method. Step 5 is to verify the adequacy of the obtained model to the sample measurements. And finally, step 6 is to obtain the PWCET, which is obtained from the adjusted model considering the expected exceedance probability. In this work, we adopted as an experimental platform a real-time operating system based on the functional and timing requirements of the RINC653 specification, which was previously implemented on the BeagleBone hardware platform. This platform was chosen because it's a low-cost, open-source, single-board computer with complex hardware acceleration features, such as a 13-stage superscalar pipeline, memory imaging unit, translation leukocyte buffers, cache memories, and an ARM Cortex-A8 processing core. According to a RINC653 specification, the system consists of an execution module composed of several partitions. The scheduling of partitions is done on a fixed and cyclic basis called major frame. In Figure 3, we have an example of partition timescale. The adopted operating system was configured with a schedule composed of 3 partitions. Figure 4, we have the timescale of the OS partitions. The tests were done by inserting benchmarks in the partitions. The ones chosen were Fibical, BSort, LMS, and Dijkstra. An execution time measurement program was used for sampling and acquiring the execution times of the benchmarks via serial port. 2 measurement collection modes were adopted in experiments: a partition-contained mode, which is in which the execution of the algorithm takes place only within the first time window of the partition itself. And secondly, continuous mode, in which the execution of the algorithm occurs in a loop during the windows allocated to the partition. To demonstrate the OS influence on the benchmark's response times, the Fibical algorithm running partition 1 was used. The other partitions remained without any task. 50,000 response time measurements were collected using continuous mode. Figure 5 shows the plot of the values obtained in clock cycles. We observe the presence of 3 distinct groups of values on the y-axis. When looking at the schedule of partitions, we can understand that at the lower group we'll have the typical response time of the task when it's not preempted by other partitions. At the center group, we have executions that are delayed by partition 2. And finally, at the upper group, we have executions that are delayed by partition 2 and 3 and by the module's default partition. The results obtained are consistent with what would be expected in this platform and operating system, validating the understanding of temporal aspects of the platform. In order to evaluate possible indirect interference effects between partitions, we used as baseline the BSORT algorithm alone in partition 1. The measurement was made with the using of the partition contain mode. In case 2, the BSORT algorithm was allocated in partition 1 as a task of interest to be measured, and the digestion algorithm in partition 2. The figure shows the resultant histograms. It's possible to notice the effect on partition 1 caused by the addition of the digestion algorithm in partition 2. We observed that the insertion of the digestion algorithm in partition 2 not only did not result in delays in the execution of the sort, but also made its execution time discretely faster than when it was running alone on the hardware, by approximately 145 clock cycles. The experiment was repeated several times, and in all of them, the counterintuitive effect remained. Using the same scenario as the previous task, we added the LMS algorithm in partition 3, and a new sampling of the execution time of this sort in partition 1 was done. It is possible to notice the effect the use of the LMS algorithm in partition 3 has on partition 1. It is remarkable that the average task execution time increased, and its variability was significantly reduced. Similar to the previous case, the experiment was repeated several times, and in all of them, the disturbancy and anomaly effect remained. That is, the insertion of the LMS algorithm in partition 3 resulted in delays in the execution of the task of interest. To perform the analysis of the MBBTA application, case 3 was chosen. That is, the sort algorithm allocated in partition 1, digestion running in partition 2, and LMS in partition 3. The measurement was made using partition contain mode. 2 task scenarios were chosen, which the task of interest varied. In the first scenario, the BSORT algorithm was chosen as the task of interest, and the second scenario, LMS. For each task, 10 different samples of 50,000 measurements were done, and 3 adjustments were made for each sample, using the BELM approach on blocks of size 30, 50, and 100, using 500 blocks. We chose to use the MLA method to adjust parameters. In this section, the results obtained for the BSORT algorithm as task of interest will be presented. Since the timing behavior is similar for all 10 samples collected, for simplicity, we present detailed results only for sample 1. Figure 8 shows the sample histogram and also the box and whisker plots of the applied statistical tests, illustrating the p-values obtained. Take into account the fact that the tests we employ are known to produce p-values that are evenly distributed in the interval between 0 and 1 when H0 is true. The values of p are acceptable, as they do not tend to low values, that is, less than 5%. Figure 9 shows the results of applying the EVT method using blocks of size 30, 50, and 100, and keeping the number of blocks fixed at 500 blocks. We have the quantile and quantile plots, which represent the ordering of the sample quantiles in ascending order on the y-axis, and the model-generated quantiles on the x-axis. The values of the model quantiles are plotted as points on the graph in which there is also a 1-by-1 line. A good fit in quantile plots is evidenced by the arrangement of points close to the 1-by-1 line, demonstrating that the model values are close to the sampled empirical values. Regarding the results obtained and presented in Figure 9, it's possible to observe some discrepancies between the curves modeled in relation to the empirical data, evidenced by the distance of the points in relation to the 1-by-1 line. However, although these occurrences are not favorable, there is no definition in the literature about the acceptance criteria in relation to displacements, and given the results often obtained in other studies, the results of all tasks presented are reasonable adjustments. In the specific case of the present experiment, we consider results obtained with a block of size 30 slightly better in relation to the others. Table 1 presents the estimated PWC-ET values with exceedance probabilities varying. In the case of using blocks with size 30, 50, and 100, it's possible to notice that the estimated values increase with the size of the block. However, it's a small variation. In the specific case of the exceedance probability of 10 to -8, the difference between the highest and lowest estimated value is approximately 30 units. To evaluate the results obtained from the 10 samples collected, box and whisker plots were created for the results of the estimated PWCETs with an exceedance probability of 10 to -8, and also of the 10 highest observed values of each sample. Figure 10 compares the estimated values by block size with the observed high-water mark. It's possible to note that under specific conditions of the present experiment, the median varies with the increase in block size, although this is not actually a significant increase, since when observed in scale, the difference in the values of the median is as small as a few clock cycles. In all cases, the medians and maximum values obtained are far from the observed high-water marks, being accepted choices for the PWCET to be adopted by the developer. In this section, the results obtained for the LMS algorithm as task of interest will be presented. The LMS task presented similar behavior in the 10 samples. However, in 2 samples, a single outlier was observed during the first 5 executions of the task. Figure 11 compares estimated values by block size with the observed high-water mark. It is possible to notice that under the specific conditions of the present experiment, the median with the highest value was identified for block size 30, while the other blocks have medians with close values. In all cases, the medians and maximum values obtained are far from the observed high-water marks, including in relation to the 2 outliers observed in 2 of the collected samples. Considering the use of the BeagleBone platform, the measurements are only valid for analysis when the configuration that will actually be applying the field is used, since what is allocated in a partition can affect the temporal behavior of a task in another partition. From the results obtained under the conditions of the performed experiments, it's possible to conclude that, in relation to scenario 1, the application of EVT proved to be an adequate alternative with satisfactory results in all cases. As for scenario 2, the presence of outliers could imply little confidence in the results obtained. However, the 2 peak values observed were found among the first 5 rounds of the task, demonstrating that their occurrence is possibly related to other initialization aspects. Regarding the totality of the experiments performed, the developer can use 2 approaches to the results obtained. Observe the 30 models and choose the one with the best fitness, or choose the highest estimate among the 30 PWCETs. In both cases, the results expect to be approximately between 1 to 2% higher than the high-water mark. From the results obtained, the MPTA technique seems to be a less pessimistic alternative to the WCET estimation if compared to usual safety margins employed in the industry.